we have sodium hydroxide reacts with phosphoric acid H3PO4 to produce sodium phosphate Na3PO4 and water. Alright, so on the left hand side we have 1 sodium and 3 on the right. Rather than treating the oxygen on the left hand side as a total of 5, it's easier to view it as you have 1 oxygen as part of the sodium hydroxide, and then you have the phosphate as a unit by itself. So you have 1 phosphate on the left and 1 phosphate group on the right. So now it's left with our hydrogen. Again, it's easier to treat them separately. So 1 hydrogen followed by 3 hydrogen. Total of 4. We'll have to keep that in mind. And then on the right hand side we have 2 hydrogen and then 1 oxygen. Let's start with the sodium. We have 1 on the left, 3 on the right. To balance that, we introduce a coefficient of 3 here in front of the sodium hydroxide. So now we have 3 sodium on the left, 3 oxygen on the left, and now 1 times 3, that gives us 3. So total we have 6 hydrogen on the left. Alright, we've balanced the sodium. Now let's go ahead and try to balance the oxygen. We have 3 on the left and 1 on the right. So let's introduce a coefficient of 3 in front of the water. And so now on the right hand side we have 6 hydrogen and 3 oxygen. So the sodium is now balanced, the oxygen is now balanced, we have 3 on both sides. The hydrogen is now balanced, we have a total of 6 hydrogen on both sides. And now the phosphate is balanced because there's 1 on each side. We have mercury nitrate, react with ammonium sulfide, to produce mercury sulfide and ammonium nitrate. Alrighty, so on the left hand side we have 1 mercury atom, on the right we have 1 mercury atom. For the nitrate, again, treat that as a unit rather than individually treating it as nitrogen and oxygen, because it makes balancing the equation simpler. On the left hand side we have 2 nitrates, and then on the right hand side we have 1 nitrate group. Moving on to the ammonium, again, treat that as a whole, as a unit, instead of treating it separately as nitrogen and hydrogen. So NH4, we have 2 ammonium groups on the left, and then we have 1 ammonium group on the right hand side. And then as for the sulfur, we have one on the left and one on the right. So we need to balance the nitrate and the ammonium group. Let's start off with the nitrate. So we have 2 on the left and we have 1 on the right. Least common multiple of 2 and 1 is 2. So let's introduce a coefficient of 2. So now we have 2 ammonium groups on the right and then 2 nitrate groups on the right. So now our equation is balanced. Copper nitrate reacts with water, good old H2O, to produce hydrogen nitrate and copper hydroxide. We have 1 copper on the left, 1 on the right. We have 2 nitrate groups on the left and 1 nitrate group on the right. We have 2 hydrogen on the left and a total of 3 hydrogen, but we'll treat it separately. We have 1 hydrogen followed by 2 hydrogen. And then as for our oxygen, we have 2 on the as for the oxygen, we have 1 on the left. And then we have 2 oxygen on the right. So the copper is balanced. The nitrate, those are not balanced. So in order to balance the nitrate, least common multiple of 2 and 1 is 2. So we need to introduce a coefficient of 2 in front of the hydrogen nitrate. So now we have 2 nitrate groups, those are balanced, and 2 hydrogen from the hydrogen nitrate, and then we have 2 hydrogen as part of the hydroxide group attached to the copper. So total we have 4 hydrogen. On the left hand side we have 2 hydrogen. On the right hand side we have a total of 4. Least common multiple of 2 and 4 is 4. So we need to introduce a coefficient of 2 in front of the water. And so now what we have is 4 hydrogen on the left and 2 oxygen on the left. And now this equation is balanced. Sodium carbonate, Na2CO3, reacts with water to produce sodium oxide and hydrogen carbonate. On the left hand side we have 2 sodium. On the right we have 2. On the left we have 1 group of the carbonate, which is CO3. Again, it's easier to treat as a unit. And on the right we have 1 of the carbonate group. On the left we have 2 hydrogen. On the right we have 2 hydrogen. On the left, we have 1 oxygen, and on the right, we have 1 oxygen. So this equation is already balanced. There's nothing for us to do. Moving on to the next problem.